Now recording. Yeah, there we go. Transcribing as well. Get rid of that so it didn't put me off. Right, okay, let's kick things off then. So hi everybody and welcome to the Welsh Azure User Group virtual meetup on the 27th of September. Yep, thanks everybody for joining. We'll give a quick introduction to the Welsh Azure User Group team as we normally do. There's a few people behind the scenes related and linked to the group. Predominantly myself and Matt will be visible on these virtual sessions. So hello from both of us. It is a community user group. So if you've got any ideas, any thoughts, any feedback, you want to speak, please do feel free to reach out to any of us. There's our details on the screen there, and say hello. And yeah, like I say, it is a community user group. So really, we want to try and get these sessions angled to really what your interests are, or what what. Like I say, ideally, if you've got something to offer the group, please don't feel you can't step forward and put your name down for a bit of a talk and come to teach us all a thing or two. So that's us. Hello from everybody here. As usual, we have a similar format tonight. Two great speakers that have given up their time to come and say hello to us. So in a second, we'll be kicking things off with John Kilmister, going to talk to us about an interesting topic around Azure Blob storage. So looking into some of the lesser known features there. So really intriguing talk. Looking forward to that one from John. Like I say, John will be kicking off in about 5 minutes or so, just after I got through a few bits and pieces. And then Konstantinos will be joining us to look at how he's using Synapse to do some data masking for PII data. And he's hooking in some Azure Cognitive Services into that as well. So really interesting to see what Konstantinos is going to be speaking about there. Really cool area. So look forward to that one. Timing wise, like I say, 5 minutes we'll kick off with John. Round about 7:30 p.m. BST, we'll be doing the session with Konstantinos. As usual, we've got our quiz with the magical quizzer. I say it every time. I never have the link to hand, Matt. So you need to put the quizzer link in the chat there.
I'll put it
if you
in the
don't know,
deck.
it is, yeah. Oh, that's true enough. It is there, but yeah, if you're wondering what quizzer is, I don't, it's probably getting to that point that we can't even mention competitors' names, Matt. But there's a session on it. If you look back through the Welsh Azure User Group sessions, Matt gave a great talk on it. But it's a quiz platform all built by the one and only Mr. Patunka there, and it's all open source. So if you want to run it in your own tenant, go and take a look at the Git repo. Yeah, that'll be straight after Konstantinos' talk, and then with an end roughly about 8:30 UK time. Next up, few housekeeping rules. As always, we go through these, but please, everybody, be do be courteous to each other. Should go without saying. There are no silly or stupid questions. That's what we're all here to do, is learn from each other and obviously learn from the speakers tonight. So, any question, don't be afraid. Put it in the chat. Please do stay on mute unless one of the speakers asks you or invites you off to come and ask your question off mute. But yeah, just use that chat facility for now. And if the speaker can't answer it there and then, or can't see the chat window, one of us will probably be able to filter back and forth, or the speaker can pick it up at the end of the session. Finally, I'll put a QR code up at the end of the event. If you're able to stick around and give us a little bit of quick feedback from that link, that would be perfect. And like I say, we got the quiz straight after Konstantinos' talk tonight. But more importantly, please do be interactive in the chat, take part, and have some good fun. But most of all, just enjoy yourself, enjoy the sessions, and be interactive. Quick word from our sponsors. Shout out, we do this every month. Of course, Servant have been with us from the very beginning of the Welsh Shore User Group. So big shout out to Servant. So you can see they're sponsoring a lot of the UK based user groups, and they really do well to offer that level of support to kind of keep these groups running to a certain extent, and give quiz prize and things like that. So big shout out to Servant. Thank you for your support. And equally, Credit Safe have joined us in recent months now. So Credit Safe being or having a local headquarters based in South Wales. Great to have those guys on board to kind of support the group and help kind of get the word of the group out. And I think we keep promising to get back to in person at some stage. It'd be nice to kind of get that network of local Welsh business as well. But equally, we love having the global nature of the audience that joins us and watches the video afterwards as well. So We'll see how we get along there. But yeah, huge thanks to Servant and Credit Safe. And I think at that point we're ready to go. So yeah, quick flying intro. So I will hand you straight over to our first speaker tonight. So Mr. John Kilmister, thank you so much for giving up your time. I'll hand over to you.
That's okay, great. It's good to be here. Let me share my screen. 2 seconds to do that. Great, so hopefully you can all see that. And as we go through this evening, if you want to put questions in the meeting chat, I'm not actively looking at it, but if we find an appropriate place, we can switch over. So great, can you see that okay? Just a thumbs up quick first. Great. So we're going to talk about blob storage and hopefully a few of the lesser known features to you. This kind of assumes a little bit of knowledge around blob storage, but hopefully there'll be enough different parts that you'll get something for it, whatever experience level you have. Before we go too far in though, I do want to introduce myself in full. So my name is John Kilmister and I've been a software architect specializing and software developer specializing in Microsoft technologies, C#, Azure for the last 20 years or so. You can find me online at John Kilmister on Twitter, X, whatever you call it now. And I have a blog at blueboxes.co.uk where I write about Azure and development and various other bits and pieces. So into the talk, we're going to talk about blob storage, but blob storage is part of an Azure storage account. So before we get any further, let's take a step back and talk about storage accounts. The first type of storage account I want to talk about is the legacy storage account. Now, this one I only mention because you might have some of these still around in your tenant. You can't create them anymore, but if you do have any of them, you need to upgrade them to V2 before you can take advantage of any of the features we're going to talk about today. If you create a new storage account, you'll be creating a V2 account. And this kind of comes in two flavors. We have our standard V2 and our premium. However, premium all focuses around Azure files rather than blobs. So in the rest of this talk, everything we're going to mention is regarding a standard V2 account. And as a quick reminder, to create a storage account in the portal, we just search for storage accounts and we go through the wizard. You can see down there under performance that we have standard and premium. And many of the other options that you see in this wizard, we're actually going to cover what each of them mean and what the impact of that is during this talk. So to talk about the types of storage account, I'm focusing in on the standard V2 one. But I also mentioned that blob storage is part of this, but there are other things to go with it. So a storage account also contains queue storage. Queue storage allows a message queuing system for millions and millions of messages on a FIFO basis. We also have table storage, one of the cheapest ways to store structured data in Azure. And finally, we have Azure Files, not to be confused with blob storage, which allows for file shares. Now, each of these on their own could have hours-long talk, and we're going to focus in today just on the blob storage. But I thought it was worth putting it in the context because as you look at your storage account, you will see these other things. So what is blob storage? Is it just a place to put things? Well, that's the way I used to look at it. As a software engineer, I would need somewhere to put my files and I would just go okay, it goes into blob storage and that's kind of it. But really it's a lot more. And as I've worked more with it and I've learned about the features, it's not just a place to put your files, but it's a way to store them securely, a way to distribute them across many different protocols and platforms. And files are becoming more and more important. They're the cornerstone of most of our applications, be that images or text files or audio files. Most applications somewhere will be storing files. So in this presentation, we're going to break it up into 3 core areas, and we're going to look at the different features that blob storage offers in each of these areas. We're going to start with actual data storage. How do we put our files? Where do we put them? And how can we get the most efficient storage. Then we're going to look at data access, because there's no point in putting your files into blob storage if you can't get them back out again. And we'll look at all the different mechanisms that we can do that. And then finally, no Azure service would be complete without data protection, backups, replica copies, soft delete, and things like that. Starting with data storage then. Well, the first thing when you upload a blob, if you use something like Azure Storage Explorer, you'll be asked what type of blob do you want. And the default blob type, if you don't specify, is block blobs. And it's important to understand these three different types of storage, because if we're going to be working with thousands or tens of thousands of files, which are broken up into blobs for the storage, understanding this can help us optimize our workflow when working with them. So block blobs, as I said, are the default type. And what it does is it breaks your file that you upload into smaller little chunks. Now, these chunks can be up to 400 meg in size. However, typically they're a lot smaller. Something like AZ copy that you can use to upload it will upload 8 meg block types. Your file can be broken up into tens of thousands of blocks. In fact, the maximum is 50,000. And this is really good for uploading, because what it'll do is it can upload each of those blocks in parallel, and it can upload them in a different order if necessary. The second type of blob is append blobs. And so these are optimizing for just keep adding to the end of a file. So imagine when you're streaming something. We can't go back and update the other blocks in those in this blob, although we can replace the entire blob if needed. And the final type is page blobs, and this is optimized for random reads and writes. And if you have virtual machines that are storing their disks inside blob storage, this is the type of storage that it'll be using. There's a lot more detail about how this works under the hood, and you can see that on the Microsoft Learn site. But for now, just appreciate there's three different types, and as we go through this talk, we will be referring back to them. The second question that you get asked when uploading a blob is what tier that you'd be using. Now, tiers can either be hot, cool, the new cold tier, or archive. And we'll go on to talk a little bit about why you might choose one over the other in a minute. But there are four tiers here. But if we don't specify one, it's just left in the default tier. And we can set the default tier under the configuration. We can just set the blob access default tier, and we can either set it to cool or hot. It's not possible to set it to cold or archived. And we can change our blob tier at any time. We can do this through any of the APIs or the UI tools. And as you can see here, we've got a blob that was added with a default of hot, so it shows as inferred in brackets next to it. And we can change it to cool, cold, or archived. So there are these different tiers, but why would I choose one over the other? Well, no one tier is better than another tier. It really does depend on your scenarios. If we take hot tier, well, it has the highest storage cost of all of the other tiers. However, it has the lowest access cost. So if you've got a lot of files that are constantly being accessed, then hot is probably the storage that you want. As we move down, the storage costs decrease, but the access costs go up. So if you have log files and you just want to store them for a little while, you might be looking at the recent logs fairly frequently, but not too frequently. So you might want to consider putting them in a cool or cold storage. Each time you access, it costs slightly more, but you haven't got lots and lots of people accessing them. Right down at the bottom, we have our archive storage. Now, archive storage is the lowest cost of all of them, and it costs about 1/10 of what the hot storage costs you. However, you cannot access the actual files themselves. You can read the metadata, but you can't look in and access it. These are good for things like long-term backups, say a database backup that you don't expect to be restoring. If you want to access these files, they're effectively offline. So we have to go through a process called rehydration, moving them back into another tier before we can then access them. Now, we can move these files between the tiers, as I mentioned, and you might want to do that in many scenarios. For example, when a file is first created, you might put it in hot because it's going to have lots of access, but over time it's less and less, and you might want to move it down to one of the other tiers. But there is a minimum time that a file or blob should exist in a tier. So in cool, it has to stay there for at least 30 days. For cold, it's 90. And for archive, it's 180 days. You might ask, well, what if I want to get it out before then? Well, you can retrieve it before then. However, you pay for the entirety. So say I had a file in cool storage. It was there for 20 days. I decided that actually I want to archive this file. You then will still be paying for the full 30 days of it being stored in cool, plus the storage for the new location. A more relatable scenario might be that you have your database backup. You've put it in archive storage because, well, nothing ever goes wrong and I never need to get it back. But then you realize you do need to get it back after 80 days. You need to restore that back out of, rehydrate it back out of archived. You're still going to pay for the 180 days storage no matter what, and then its new storage location cost as well. The exception to this is if the default tier was cold, and then you move it, cool, as the typo in the slide, if it was cool, and you move it to archive, then you aren't charged the early deletion fee. But it only applies if the default tier took into effect and you didn't explicitly set a tier yourself. So I mentioned about rehydration. So if we've got that file in archive, we want to bring it back out, we go through the rehydration process. Now, this can be triggered through the UI tools or through the APIs and various other mechanisms, and even through the portal. A standard rehydration can take up to 15 hours. I've had it take varying lengths of times. If it's urgent, you can mark it as high priority, and you can actually upgrade from standard to high priority later if you want. But you can't downgrade. You can't choose high and then go back. And at some point in that time window, your file will move into the new storage tier, and you'll be able to access it. Now, how do we know it's moved? Because 15 hours is quite a long time. Well, we could just check the blob properties again using any of the APIs, the UI, and various other mechanisms. Even just looking in the portal, it will show you a status change. But again, over 15 hours, you can periodically check back, but that could be quite frustrating. And if you've built an application around it, you don't want to keep having to poll the storage account. So you can subscribe to Event Grid, and you can attach your account to Event Grid, and you will get a new notification in Event Grid on tier change. Once you get that notification, you can then go and look at the blob properties to see what that tier change has been. Now, all of that was manual moving, and that might be fine with log files or database backups. But if we've got thousands or tens of thousands of files, think of, say, end of year accounts that we're wanting to work with those files a lot, and then we need to put them in archive because they need to keep them, but we don't need to access them. How can we do that in an automated way? We can do that with lifecycle management rules. These can do two things. One, they can move between different access tiers based on a set of rules, or they can delete blobs outright. So you might delete logs after 7 days, for example. Where can we get this? Well, inside the portal, we can go down to lifecycle management rules and we can configure them in there. We'll actually have a look at that in a minute. But some example rules, we might want to move from cool 30 days, move to cool 30 days after created. We could move it to cold 90 days after created. We could just decide after 7 days of it being updated to delete it. And log files are a good example with that. Or we might move to archive 30 days after it was last accessed because we've come to the conclusion that we don't need to use it anymore. We'll have a quick look at this now. We'll just quickly switch across to a demo. And I have an account that I set up here previously. Hopefully it's not going to be too slow for us this evening. Hopefully, if it gets too slow, we might have to drop the demo. But okay, so from the lifecycle management in here, we can click Add Rule. Now, before I click Add Rule, there is this little box here that says enable access tracking. When we add a rule, we have the option to do created date, base rules on the created date, but not on the last time it was updated. If we want to add rules based on updated dates, we need to enable access tracking. That does incur an extra cost, so it's worth reading up about that. But it is useful to have that because you might want to only archive after it was last accessed rather than when it was created. So for now, I will tick that box quickly on my account, and as you can see there, it's updated the account. That will now start tracking files. I will click add rule. Got to give it a name, so I'm going to go delete 7 days after access. I can set here if I want to use all blobs or actually filter them based on a path. And our block type, or our blob type, sorry, has come back. So you can see here we can just do the block blobs, or we can also include append blobs. And then there's some subtypes which we'll cover later on. But for now, I'm just going to do block blobs. Now here's where we create the rule, and because we tick the box, last access to the period, and then we'll just put in here that we wanted it to be 7 days, and then we can choose what to do, and we can delete it. We can move it to archive. In this case, we're just going to delete it. We click add. That can take up to 48 hours to run the first time, and then it runs once a day, every day, while it's still enabled. So I'm going to just quickly switch back now to the presentation. Okay, some other things about blobs when we store them, as well as the actual file data, the blob data, we can actually read a set of properties. These are predefined, things like the blob tier. But we can also add our own metadata or our own index tags. Both metadata and index tags are key value pairs, but index tags allow you to search on it as well. We can search on metadata, but you have to index it with Azure Search. So that was a very quick overview about storing blobs. But how are we actually going to go and access these and give our users access to them? Well, the first tool I want to point out, and you've probably, if you've used blob storage, you've probably used this tool, but it's Azure Storage Explorer. It's an open source cross-platform tool that you can go and download, and it allows us to log in using our Microsoft account and navigate through our blob storage containers, upload, download, change tiers, and do many of the things that we're going to be talking about this evening. Behind the scenes, this is actually using AZ copy. We'll come on to that in a little bit more detail next. One thing I wanted to highlight, though, is that many features that you can find in Azure Storage Explorer have now been moved and added into the Azure portal under the storage browser. It's not a one-for-one copy. However, it does allow us to do many of those features and is quite useful for doing a quick set of actions. I mentioned AZ copy there, and if we're doing anything with a large number of files, AZ copy is a really good tool. It's a cross-platform command line tool that we can use with our Bash and PowerShell scripts, and it's optimized for working with large numbers of files in the most efficient way. What we're going to do now is quickly just show you some of the commands, give you a bit of a flavor of what it can do, and maybe point out some of the ones that you might not have known about. So basic upload is kind of the bread and butter of this tool. You use it, say, command line, so AZ copy, and then we can pass it a folder or an individual file and a container. With this particular command, we can also pass it a pattern. So we can say, OK, we want all PDF files to be uploaded or all files that match a certain pattern. And that's quite a standard usage of it. Now, I mentioned about it being a performance tool, but how do we know how long things are going to take? If we've got 10,000 files to upload, we can use this upload command. But what if we want to know beforehand how long it's going to take? Well, we can use the new preview feature called benchmarking, and we can pass it a blob storage account. We can also pass it a load of parameters, things like how big should those blocks be, or how many files should we upload in parallel. And all of those then get fed in, and it uploads some sample files and gives you a load of metrics back out to tell you from the machine that you're using what the performance will be like. So a really useful tool if you've got a lot of files to upload and you want to work out what the optimum settings are. We can also do remote copy, so we can use this tool to copy from one blob storage account to another, and that isn't limited just to Azure. We can copy from a AWS bucket or a Google storage account over into blob storage using this tool. And as it's a remote copy, it doesn't download the files beforehand to your local machine before it has to upload them again. Another useful command is local sync. So we can give it a folder and then we can give it a container and we can ask it to keep those two things in sync. Now, all of these tasks get processed as individual jobs, and this has lots of benefits. One of which being is that we can track the progress by doing AZ jobs list, and we can list out the jobs that are currently running. If any of the jobs get interrupted, they can actually get restarted, and we can do that using the AZ copy jobs resume feature and passing in the job ID, and it will resume it. So there is a lot more commands that you can do with AZ copy, but if you're working with a large number of files or multiple storage accounts, or you want to be able to script tasks with PowerShell or Bash, and you want to interact with your storage account, AZ copy is a really good tool for doing that. As I say, it's cross-platform and open source. But what if we want to give other people access to our blobs? Well, the typical way of doing this is through access keys, SAS tokens, or policies. The access keys, like most things in Azure, there are keys that will give you access to the entire resource. And it's discouraged to use the access keys on a storage account, and you can actually turn off their usage under the configuration. But there are still cases occasionally where you may want to use them. We typically generate SAS tokens, and a SAS token can give you access to an individual blob or a whole storage container. And on that, we set it up with certain permissions, a start time and expiry time, and potentially a set of allowed IP addresses. That generates as a URI, which we can then share and people can then download the individual file. If it's targeted to a container, they have to use something like AZ copy or Azure Storage Explorer to access that. You can also use these SAS tokens with the APIs as well. So if you've got an application, it can generate a SAS token. It can then use that SAS token to access the file. Now, these SAS tokens, as you can see there, have all of their details in the URI and has a signature to make sure it can't be tampered. But we can wrap all these permissions up into a stored access policy, and then we can generate multiple SAS tokens that all point back to that same policy, which is quite a useful technique. Another feature I want to talk about, something that's relatively new, is SFTP. So with the SAS tokens, as a general rule, you do need to be quite technical. You need to be able, or at least have access to things like AZ copy or the Azure Storage Explorer, or we need to write a custom app. What if we've got, say, a web developer that just wants to upload a load of files, or someone that's got an account spreadsheet and they just want to upload it? We can use SFTP. We're just going to quickly look at how we do that. So in this demo account here, you won't see any mention of SFTP. You can see on the left-hand side here, the data management configuration, there's no SFTP. And that is because this account does not have hierarchical namespaces enabled. Now, hierarchical namespaces, you can see here, it's disabled. When you upload blobs to storage, it may look like they have a folder structure. However, that a lot of the time are just tools looking at the name of the blob and separating on a / to emulate a folder structure. When we enable hierarchical namespaces, we get a real folder structure, and that is needed for SFTP. We can upgrade this account to enable hierarchical namespaces. That's done under Data Lake Gen 2 upgrade. But there are certain things that prevent an upgrade happening or cause you some challenges. So it's often better if you know ahead of time to enable it. And I have another account here, which I've already got it enabled. Once it's enabled, we can scroll down and we can see under settings SFTP. And from here, we can click in here and we can create individual SFTP accounts. So with this, we can create SFTP accounts either with an SSH key pair or with individual passwords. So it's as simple as just clicking add local user. We then specify the username. If it's going to let me do it with the, here we go. So we specify a username. I'm going to call it demo2. And then we say if we want to use the password or the SSH key pair being more secure, but for now we're just going to create a password. Then we select what container we want to share. We can share any container or create a new one. I thought I had one created, I don't, so I can create new. And then you specify a home directory. Once that's done, it will then generate you an account and show you the password to share. And you can see that there. Details that you can share to someone else, and they can just use SFTP to upload those files. A feature that I want to quickly show is about static sites. So we can share files by SFTP, but what if we want to put up like a mini website that just lists a load of files? Well, we can do that through static sites. So if I go back now to my other account, and on the left-hand side here, we can see static websites. When we enable static websites, this will create a new storage container called $web, and it gives us a URL that we can visit to hit that website. So here we go, we enable it, and then when it saves it, it creates it. We can also specify a default document name, and this is important. So if we had a blob storage container and we enabled public access, you could just navigate to that in a web browser and see the individual file. By default, anonymous public access is disabled on storage accounts, so you'd need to enable that and then create a new container and choose at that time to make it public. But in theory, you could, but you would need to specify the entire file name. By doing a static website here and specifying a default name, then we don't have to specify the full file name. We can just give it a URI. So that's enabled it. And if I go to storage browser, I'm hoping this will work on the connection that I'm on. We should see, here we go. If we go into blob containers, we'll see we've now got a $web, which is new, and it is a private container. And we can upload our files. These are relatively small files, so I'm hoping they'll upload pretty quickly. So I'm just going to browse for that. So I've got a nice picture there and a web page. And click upload. That takes a few seconds to upload. They're uploaded. Now, how do we access these files? Because the actual storage account, as mentioned before, is marked as private. So you can't choose the public endpoint on it. Well, if we go down to endpoints here, you can see the static website address. I have masked that. So there we go, static website address. So we can put that into our web browser and we will get, hopefully, the website. Now, this is a feature that's been in storage accounts for a little while, and it might not be new to you. Oh, look, it's loaded. So yeah, it's a feature that's not that's not that new. However, one thing that is new is if you wanted to set this to have a custom domain name, it was relatively complicated to do. You could do it with HTTP, but if you wanted HTTPS, there was loads of hoops you had to jump through. They've now fully integrated front door and CDNs into storage accounts. This means that we can not only set our custom domain with a free SSL cert through front door, but we can also enable things like a WAF or enable caching and various other things. Also, the addition of a CDN, if you just want CDN rather than a full website, means you can keep your blob storage private, however, still have your website access files files through the CDN and into your storage account. So the experience is a lot better than it was previously. But you might be asking, why would I want to do that when I could just use an Azure static web app? And that is a really good point. As I said, static sites on storage have been around for a long time, although we've now got some nice new additions. Azure static web apps are relatively new, been out a year and a half, 2 years now. And actually, if I was creating a website, I would probably go with the Azure static web apps. The one time that I would use the static sites on storage is the direct file access. And this is the big difference between the two. With static sites on storage, you can see all the files that are part of that site. And if you've got a new spreadsheet to upload into that storage, someone can download it, you can upload it using any of the APIs or the tools that we've seen so far. With a static web app in Azure, you have to go through a build process. So that's a GitHub or DevOps pipeline, and it has to publish your website to the Azure Static Web App, and you can't get access directly to the files. There are also a few other limitations. For example, if you have a large amount of files, you might hit the limit, storage limit on Azure Static Web Apps. So for most things, if you want a website, you would go with Azure Static Web Apps, but it's good to know that static sites still have a use, and they've made the experience much better for that. So other ways of accessing the files, well, I've mentioned the APIs multiple times, and yes, you can access everything that you can through the tooling, through the APIs, but that can be complicated. So there are a large number of client libraries that are wrappers around the APIs and that take advantage of all of the features that we have in each of the languages. So if you're used to working with Node.js, you can just go in and use very similar syntax to what you'd be using with any other package to interact with your with your storage account. And that means you can change tiers, you can allow people to rehydrate from archive, along with creating containers and many other things as well. If you are using any of these APIs, Azurite replaces the storage emulator. So there used to be a storage emulator where you could have a local version of storage. That's now been replaced with Azurite. So if you are working as a developer, it's well worth having a look at that. Another thing I wanted to mention about giving access to people are blob leases. So we can take an exclusive lock on a file through the use of leases. Once you select a file and acquire a lease, you're given an ID. You need to then provide that ID for every further action you use. Otherwise, the operation will fail until the point you break the lease, and then anyone can access the file again. So that's a lesser known feature that can be quite useful if you do need an exclusive lock on a file. A few other features we didn't get a chance to talk about are NFS file shares. So if you are on Linux and you have enabled hierarchical namespaces, you can then attach an NFS3 file share, which can have a number of uses. We can attach Azure Search directly to your storage account and start indexing the files that are in there. The storage mover. So if we're moving and doing a migration project, we can use AZ copy. However, Azure Storage Mover is a relatively new feature, and it installs an agent on your server and helps you with migration. So if you're doing any migrations, it's worth having a look at that. And finally, I wanted to mention metrics. So the costs can be very complicated. So you get all of the cost analytics, but also we can see how many are in each tier, how many blobs are in each tier, and usage and various other things just using standard Azure metrics that are provided for you. This brings us on to the third and final section, which is data protection. And as I said earlier, no Azure service would be complete without it. And we'll actually see many of these features in blob storage reflected in other services across Azure. But the first thing I want to talk about is replication, and this is probably particular to storage accounts. And it's one of those things that you get to pick when you create your storage account, but not everybody fully appreciates what it's doing under the hood and why you might pick one over the other. If you are interested in this, by the way, the Microsoft Learn site again has a really good good documentation on this, and I have taken the screenshots from that. So if you're interested, do have a look more. So the lowest level and cheapest is locally redundant storage, and you actually get 3 copies of your files, or your blocks, should I say, in this scenario, but they are all inside one data center. We then got zone redundant storage, and in this scenario, it's still in one region, but our 3 copies are now distributed across different availability zones. But what if we lose a whole region? Well, that's where zone redundant storage comes in. This time we have 3 copies in each region. But something really important about this is that you can't get access to those copies in the secondary region just by enabling geozone redundant storage. What will happen here is that you will always access the primary region, and then if there is a full outage, the DNS will be switched over and you'll be pointed to the secondary region. But this could take some time, and there will be potentially there will be an outage in there, and that may or may not matter dependent on your scenario. But if you don't want an outage, then you can use the RAGRS, the read access geo redundant storage. But it's worth noting that your application code, if you're writing custom application, needs to be adjusted to read from the secondary region in addition to reading from the primary region. So yeah, that's our basic setup, and each of those cost a different amount based on the tier that you're using and the replication factor. The SLAs are also slightly different. You get an additional 0.09 if you go with the RAGZR. But all that information, as I said, is on the Microsoft Learn site and is well worth a read. That's all well and good if we lose data center or we've got something outside of control. But what if our users just overwrite a blob? It's gone. Well, that's where versioning comes in. If we enable versioning, every time someone overwrites an existing blob, all previous versions are kept for us. And we can view those versions in all the UIs and the various things just by right-clicking View Versions, and then we can get back to any of the history. And you're just charged for the delta of the blocks between your original and the version. So again, this goes back to that very first slide about the different types of blobs and the block sizes that have been chosen for you. Depending on your scenario, you might want to adjust your block size because it will have an impact when it comes to things like versioning. Versions can be at different tiers, and if you change the tier of a version, it will then be charged at the full version, at the full price, rather than the delta of the blocks, because it's in a different type of storage. Now, you can end up with lots and lots of versions because it is automatic. So this is where lifecycle management rules that we saw earlier also come into play, and it is recommended to set those up if you are using versioning, so that we don't end up with an infinite amount of versions. And you might want to delete versions after a certain number of days. So that's all well and good. It's going to take backup copies of everything that's overwritten. But what if you want more granular control over it? Well, that's where snapshots come in. And snapshots are much like versions. However, snapshots are manually taken. You have to take a choice to actually take them rather than them being made for each copy. Snapshots can only be made for hot and cool storage. And just like versioning, you're charged for the unique blocks unless the snapshot is on a different tier. That's all well and good for overwrites, but what if someone actually goes and deletes your blob? Well, that's where we can use soft delete. Soft delete occurs in many of the Azure resources and is available for blob storage. It can be for the blob itself, or it could be for a snapshot or for a version. Configurable for 1 to 365 days. But as with most soft delete, you are charged until the fact it's actually finally removed. One of the things that, if you move to hierarchical namespaces, that isn't supported is soft delete. So if you're wanting to enable FTP or NFS 3 shares, you need hierarchical namespaces, and in turn won't be able to use soft delete at this time. How do we get the blobs back after soft delete because they're not there anymore? Well, we have to, they're still accessible in tools like Azure Storage Explorer. We have to change what blobs we're viewing. So here you can see we're only viewing the active blobs. You can drop that down and get access to the other blobs that have previously been deleted. And in the top right there, we can see we can then undelete the selected item or undelete by a date range, which can be particularly useful. But there's much more to data protection. Unfortunately, we don't have time to go through all of these things, and some of them are quite detailed, but I'll briefly touch on them, and then if you're interested, you can go away and look further. The first one is immutable storage. So there are some times when you have regulatory requirements. As soon as a file is placed in the storage account, you want to make it so nobody can do anything to it. They can't move it, they can't delete it, they can't do anything. And this can be done through immutable storage policies. You create a policy and then that's enforced for that duration. And not even Microsoft can alter the files during that time. So it's quite a big topic, but if you do have that regulatory requirement, definitely have a look at that. We can do point-in-time restore of the entire storage account. We can also do Azure backups as well. We can link it into Azure backups. If we want an audit log of everything that happens in your storage account, you can use change feeds. When you enable change feeds, you get another storage container and log files get written in there with a list of every change that happens. Again, particularly useful if you do have a regulatory requirement for it. And the final thing around data protection that didn't quite get time to cover is Azure Defender for storage. Like a lot of Azure Defender products, it is very broad. The storage one detects threats on your storage workloads, including malicious access, sensitive data, and malware that's been uploaded, amongst other things. But again, hopefully these are just a few pointers that can spur some interest and you can go away and have a look a bit further. So that's what we're going to cover today, and hopefully there's been a few little snippets there but you may not have known about, and a few little things. We covered data storage, so looking back at the different tier levels and the different blob types, from block blobs to append blobs to page blobs. And later on, we then talked about how they can have effect on some of the features that we're looking at. Then we looked at data access and how we can use some of the free tools that are provided, such as Azure Storage Explorer, Storage Browser, and the CLI tools, but also how we can give access through SAS tokens and provide access through FTP and file shares and various other mechanisms. Before finally finishing up and looking at the all-important data protection on replication, versioning, snapshot, soft delete, and a number of other features. So that brings us to the end. And I haven't had a chance to look at the questions yet, but no doubt there's be some interesting ones in there. So I think with a few minutes left, if there's anything in the chat, we can take a look at those. So the one question that I see from Joe there is, how does Blob Storage static website differ from the Azure service? And it says, you read my mind, John. So hopefully I've covered that in enough detail. And if you do have questions, further questions, do type them in. But for me, it's really around the amount of data that you can store. I think my recollection is that there's a 250 meg limit on Azure Static Web Apps. I think somewhere near that. I've hit it before. And also you can't get access directly to the file. So they're the two big things that stand out for me as differences. So yeah.
That was awesome,
Are there
John.
any other questions or even just general comments or thoughts?
It's like you saying at the beginning, I think storage accounts can be probably overlooked with all the features and functionality that they've actually got in them. And I think until you actually sit down and spell a lot of them out, it's you know, I've seen it myself that it's news to a lot of people. So I think that was a really great overview. Thanks.
Yeah, that's what I found myself, really. That's what I found
Mm.
myself. You kind of, and they keep adding features, so you dive in and use it, and then you come back and it's like, oh, there's another feature, and it takes time to go through and work your way through how they can actually benefit you. But like the new addition of cold storage, that could save quite a significant amount of money if you've not looked at it before. With moving files between tiers, though, you do have to be careful of costs. Obviously, there's the early deletion fee, but there are other fees involved about moving files around. So, yeah, definitely have a detailed read of the pricing tiers if you're looking at that kind of stuff.
No, absolutely, John. No, I think it's one of those things I'm working with customers on at the moment, is that kind of life cycle management. How do they kind of go through the tiers in the most kind of efficient way? So it's you know, it can be a little bit of a dark art at times, but it's, you know, it's just about knowing what you're using your storage for, I guess, isn't it? But no, John, that was great. What's that? I can see Nicholas has just written something there. Your storage account seem more coherent than their AWS equivalents. Yeah, potentially the next 3 buckets. I mean, there's certain features there, but yeah, I mean, Microsoft seem to be, like you say, adding feature upon feature every time you look at a storage account at the moment, don't they?
Yes.
But,
yeah.
no, but that was brilliant. Thank you so much, John, again for giving up your time and coming and saying hello to us again. Always appreciated. So, yeah, if everybody wants to show their appreciation for John using the emoticons or come off
Well,
mute, there we
thanks for
go.
having me.
See you clapping hands. No, anytime, John. Always good to have you back on the Welsh Azure user group. But yeah, we won't leave it so long next time before saying hello again. But
Yeah.
stick around as well. Yeah, stick around for
I will do.
Konstantinos'
Yeah.
chat, and obviously feel free to join in the quiz at the end. We've got actual prizes and all that good stuff. So, but no, thanks again, John. Catch up soon. Yeah. So on that note, then, Konstantinos, we'll hand straight on over to you if you are there. I think you're on mute. The dreaded mute.
Hello.
There we
That
go.
was a
Loud
great
and clear.
presentation from John. Thank you for having me.
Great, yeah, not at all. I'll leave you to it. Leave you share your screen, and looking forward to seeing your presentation.
Sure. Let me share my screen. Great. So my name is Konstantinos. I'm from Greece. I work as a solutions architect. I have various certifications, mostly from Microsoft. I love the Azure ecosystem. I've known it for 8 years now, and I just love it. One of the most important certification I got, who actually led me to learn a lot of things, it was the solutions architect and the DevOps engineer, and the virtual desktop, of course, which is you know, something that I like. I'm also a Google Cloud architect professional and an MCT. I recently obtained the Terraform certification because I work a lot with Terraform, and we will start today with Terraform. Our workshop is a solution provided by Synapse Analytics via a template. We can mask our personal identification data with the use of Synapse Analytics and Cognitive Services. This workshop was quite a large one, so I didn't want to, you know, start from the scratch. So I will present a little bit of the Terraform configuration using Terraform Cloud. We can have Terraform Cloud for free, and we just need to configure a little bit on our computer. It's just a file that we have to add on the user data folder, and how we syntax our provider's file. I will show you now for quickly. And this is the provider's file. Whoever is on Terraform will understand that we just need to add this portion here, and a token that we obtain from the cloud portal of HashiCorp. We just add it to a file into our PC, and then we can connect from our laptop to the Terraform cloud and start deploying. So the point is that when we apply a configuration, we are able to obtain a URL directly on the terminal, and we can click on the URL and go to HashiCorp Terraform Cloud Platform and see what's going on. Of course, we can apply as well. We can have different work spaces, different organization, all that for free. The point is that we have our Terraform TF state file stored here in Terraform Cloud if we want to. Just a quick look, we created a Terraform configuration with cognitive services, a data lake storage account, and John did a quite extensive reference there how we can activate the hierarchical namespace, which actually also enables the storage account to be a data lake storage version 2. And that's what we did with our storage account. We just enabled hierarchical namespace. Here is the details of what happened. We have the ID of each resource on Azure. And let me show you quickly what we did here. I'm bypassing all the Terraform configuration because it will take time to create these resources, and the Synapse part is quite big too. So we created one resource group, and because we are creating a Synapse Analytics workspace, it will create another resource group which is managed. We can see what's going on here if we activate the show hidden types checkbox. So we will get an SQL server and an SQL database. It is provided when you create a Synapse workspace ready for you. So here is actually what we have created. This is our data lake storage. You can see that it is a data lake, or it has hierarchical namespace enabled by this icon. You can quickly understand that you have an hierarchical namespace enabled, so it is a data lake storage. We have a simple blob storage here created also. These storage accounts will serve as input and output for our data. So let's go quickly to the Synapse workspace. Let me get back here. We have also a Cognitive Services multi-service account and our Synapse workspace. When you click on the Synapse workspace, you can go to the Synapse Studio, which is right here for us. Now, we want to create the linked services, meaning that we have to connect our Synapse workspace with the storage account and the Cognitive Services as well. For the sake of it, or just for fun, we will not use the ready-made connector for Cognitive Services, but we will use the REST API just to see how we can talk to the Cognitive Services via a REST API call directly from Synapse Analytics. So the first thing that we have to do is to integrate. We are going to create a new linked service. Let me get back to this. What I'm going to do is I am going to create an export of my Active Directory usernames. I will export them as a JSON file. We will do that together. We will upload them to the Blob storage account. Then we will create a pipeline that will transform the JSON file to CSV, and we will execute the data masking on that CSV file through the Synapse Analytics. So we want to create a linked service. Let's go and find the REST API. Our Synapse Analytics provides various connectors. We can give it here a name. Let's name it Cognitive Services. What we're going to need, of course, we need the endpoint and the key from our multi-service account. The reason I have come down to the REST API is because when I used some months ago the direct connection with Cognitive Services, I had some problems. I'm not sure if this is fixed, but let's take the safe road. And as I told you before, let's do it for the sake of it, because there is a little, nice thing here we have to add. So you understand that we have to add in the headers here, this header. Let me remember it. I don't know everything from my mind. And we will enter here the key. We can take whatever key we want, key 1 or key 2. And hopefully we can test the connection and see that it will work, and we can see that it is working. Let me zoom in a little bit so you can see a little better. This is our first linked service. Via REST API, we are connecting from Synapse to the Cognitive Services account I have already created. A little bit of information: when you are creating Cognitive Services via Terraform, at least until now, the documentation still refers to it. We have to create another Azure AI account, so you have to accept the terms of responsible AI. I think at least in the US regions, it is mandatory to do that. So just for your information, in case you try to do this same workshop, here is our first link service. Let's create a second one. We will use the blob storage. We will use directly the subscription which we have our storage accounts, and the connection is successful. This is the second linked service. This is the blob storage account, and we create another one. You can see that it's already here, created when the Synapse workspace was provisioned, but we will create our own. We have a better control, know what we are going to do. Let's leave it that way. Select our subscription, and this is our data lake. If we have time at the end, I will show you the Terraform configuration and with the random here, the random characters that we can insert directly to the code, so you can be sure that you have random names and you don't have to worry about naming when you're creating resources directly from the code. Okay, now we have our linked services ready. Cognitive services, the blob storage, and the data lake for our workshop. The next thing we have to do is we're going to need a JSON file. I will display this for you into my screen. I am connected already to MS Online Service. This is the command, okay? And this is the second command. I will copy paste from my site. This is what we are exporting. I'm sorry for that. We're getting the user. It is licensed. Anyway, the script, anyone can create the script that he likes. We are exporting our users into a JSON file. That's great. Now, the next thing, let's use AZ copy. I am sure I have AZ copy. If I don't have it, I will upload my file directly to the blob storage. Later, we can see how we can do that with the AZ copy. It is not a hard thing for you to do, but to save some time, I will upload directly my file to the blob storage. When I created the infrastructure, everything is created via Terraform code. So I have already a container here named AD users data, and I am going to upload the JSON file I just exported from my Azure Active Directory. The point that I did it, the JSON file, is for you to see that Synapse allows us to create pipelines that make data transformations. A very simple one is to change the JSON file to a CSV. Let's go there and see how we're going to do that. We are going to ingest our data. Let's go to the home screen. Here you can find ingest. This is the fastest way to create a pipeline for data ingestion. You can see that you can have it on schedule. So, for example, if this workshop fits for a specific day-to-day job, you can run it every morning or every 3 hours or whatever. We will run it once now and maybe once later to bring our data. Our source is the blob storage, and we have already our connection here. So you can see that directly when we select the blob storage linked service connection we added before, Synapse GUI brings us the various configurations that we can select. So here is our file. Let's select it. We don't need recursively to add something here. This is the file. This is the input, the source. Okay, the source data store. This is our file. Now we can preview data. Okay. We can configure different settings here. Our format is JSON. And the destination will be the data lake storage we have created. It is the data lake connection here. Now, our folder path is going to be this one, the out files. And we can proceed and give a user and a file name here. Let me find this. Let's give it a name and we will find it later. Out users.csv. Remember, this is the first task. This is going to be the input file for our data masking later. So we provide the user, the file name, I'm sorry, and we configure later how we want this to be ingested. We will need to add the header to a file because we have columns and rows that have, the user, the when created, password, and all that things. I think the setting is correct. Here you can add, you can make changes here, but everything is string. So let's select string for each of our input values. What is this? User principal name. I need string and string. So it does understand the structure of the file, and the mapping is correct from the JSON to the CSV. We just need to add the type here. You can leave out whatever you want, or you think that it's not necessary to come up. And this is our copy pipeline number 1. This is just a small display of what Synapse Analytics can do for us. We can create data transformation pipelines with ingestion and the sync, which can be our storage accounts. As you saw earlier, when we created the connections, we have a lot of services that can be integrated with Synapse Analytics. This is our first pipeline. So you can see now that if we go to our data set, of course, here we have our pipeline, and in our data, we have our data set here. This is the destination data set. We can see all the details. Okay, and this is the source data set, the JSON file we exported earlier, and this is our destination. Okay, we will work now on this file. The CSV file needs to be masked. Okay. Of course, we can preview if we want to, and we can import a schema if we want from a sample file or from the connection that this dataset relies to. Remember that we have to publish usually when we have 2 or 3 changes here, so we know where we stand regarding our deployment. Now, the next thing we have to do is to start with our cognitive services masking. I will go to the integrate menu and I will add a new resource. Here we can see various selections: pipeline, link connection, copy data tool, and browse gallery. The gallery has a lot of templates here, right? You can see what's going on here. A lot of things that we can use and adjust to your requirements and needs. We have here the personal identification information detection and masking. It is from Microsoft. Let's use this template. This template was built on data from COVID, I think, but we will have to adjust it for our own purpose. So the first thing we have to add is the PII detection is here, the cognitive services, and the source is the data lake. Okay, so when you import the template, you have to select where is your source and what service will perform the personal identification information detection and masking. So this is our pipeline, and here we are. Now let's bring quickly our copy pipeline with a simple copy in this tab. It's very easy. So you can see here that we can connect on successful execution when, for example, data is correctly ingested. Let's go here and do the data masking. So this is a nice start for us. We have a little pipeline that just copies data from a JSON file to a CSV. When this is successful, it will go here to run the data flow. Now let's go here and start the difficult part where we have to adjust our template. Excuse me, because I'm looking on my blog. It is quite a difficult one, as you can understand. So first thing first, here you can see that we have one reference with 22 columns. This is from the template that the user that created this used to have. We have to change this, and we will see that this will change to our number of columns. If I remember correctly, it's 7. I can see it also here on my blog. So our source is an integration dataset that we have on our disposal, and this is destination dataset. All right, don't mix it up. You can change the name here, but we know it. It is the destination dataset because our pipeline brought the source to the destination. It is this. We know it. Of course, we can open and see it here, if I remember correctly. Yes, and we can see that everything is correct. And let's return to our pipeline and make it a little bigger so you can see better. Great. Now, the next thing here is to enter the correct expressions for our own dataset. You see that we have an error here because, of course, this expression is reflecting to the data that was inserted from the user that created this template with other data, So Let's go to the expression builder. I will not write it by head. I have it ready, and I hope the copy paste works correctly. I had some trouble in the past, but don't worry. I think everything will be all right. Okay, the first expression is corrected. We can return later and see it again. We will do that. You see that these are the columns from the previous dataset that the other user used when created the template. We are adjusting this to our own template, to our own data. Great. This is the second step of the data flow, which is the create request body. Now, let's go back here. You see that the column change. We have 7 columns in total, meaning that we are in a correct path. I think that we will not see errors from here. This one is one of the most difficult parts to create. Now, let's also fix this. We need to edit these parameters for this flow. The source file system, I remember it. We have named it FSys, is from the data lake, right? The source file path, it is the folder name outputs on our data lake also. And I don't remember the name of the file, so I can go here to my storage account. I should have keep it somewhere, but it's not a problem. And just verify also that we have here our file. It is outusers.csv. So we just have to enter the correct file name. Yeah, it was COVID data. Out files. I think it's plural. Out users. I'm sorry. Out users. Now we have the correct parameters also for our data flow. Let me see if we are missing something here. I think I can publish now without errors. Yes. Let it finish. Yes, everything looks fine. Here is also the parameters we have to correct. These parameters have to be corrected into 2 places. Okay. Now, let's correct this one. The source file system is, sorry. The source file system is FSys. The source path, it is outputs. It is a folder of our data lake, right? And here we have the out users.csv. Yes, let's republish. I think everything will be fine. Good. Let's keep this environment a little bit cleaner. So I'm closing these tabs. We don't need the source or the destination dataset. We need this flow and this one. So let's continue to the final part. The sync. When you are working with Synapse Analytics, you will see a lot of these, um, expressions. The ingestion, which is when we are taking data in, and the sink. It is where are we going to put our transformed data. So where are we going to put our data when it passes this transformation? Let's see. We will select the inline selection available to us. And in the settings, yeah, I have to select the dataset, of course. The inline dataset is our delimited text, and it is the data lake connection. Great. And now in the settings, I can browse to my file system of the data lake storage account and find the path. This is the folder path. First row was header. Don't forget that when you have to do with data that has headers. We don't need anything other here, but we need the file name. So let's find our file name option and find it here. First row was header, file name option. It will be output to a single file. And the file name here, let's say it is masked.csv. Now, what will this action do? It will create a new CSV file that will present the original data on the first column and the mask data on the second column. We don't need anything else, as I can see here. I can continue. Yeah. I'm going to publish once more. Yeah, we have an error here. We will fix that. I think it has to do with the mapping. No, this is fine. The single partition, I think is what we need. Yes, the data flow is ready. Now, what we are doing here, we are taking our ingested data from the data lake storage, a CSV file, which got transformed from a JSON file from the first copy pipeline. This one here. We create our request for the body of our file. We are calling the cognitive services to create what we need. You can see here that we have the linked service, right? It makes a flatten on the results. You'll see that we will have this reference here, so we know which data is masked or redacted as it is referenced to, and will be our final sync file. I think we are ready to execute. Let me have a final look. Yes, we have published our changes. Let's have a quick look on our file here. That it has data, otherwise I will add some users. You can see here that this is our file. This is our exported users from the JSON file that got transformed to a CSV from the first pipeline that is still on our interface. So this is our data. We are expecting some of this data to be considered as personal information identification and get masked or redacted from the cognitive services account that we have created, right? Okay, let's see if everything works as expected. Now, I will trigger the first copy data task, and if everything is done correctly, it will continue and will execute our data flow that we configured earlier. Let's do that. It is running, and we can view the pipeline run. If anything comes up here, we will see. In case, for example, there's an error or anything that will stop the pipeline from running. We really hope everything works as expected. Synapse Analytics is a great tool, and with the use of the integration runtimes, we can do a lot of things regarding securing our data flows. We can use the managed virtual networks, managed private endpoints, and really create a very closed system for data analytics. And, I have access now from the internet, but I could have created a virtual machine inside my subscription and access Synapse Analytics workspace from a private endpoint. Synapse Analytics also supports a private link service for Synapse Analytics, which is great for your data transformation and data analytics uh, pipelines or tasks. And, security was not that important 10 years ago. But now security has come forward and helped us to create better services. I think Microsoft has really done a great work with securing the endpoints of the resources and the services, so we can really learn how it is working in the context of how security is applied. This is great. At least it has helped me quite a bit to understand better how some services work, because I have to know and learn how security works and what is a service endpoint or a private endpoint and why should I use that. It is really great. It will take a little bit of time. In the meantime, let's return to our code here. I was looking to close VS Code, but I think it's running smoothly, so I will leave it open. Let's have a look here on our Terraform files. For those that are working already with Terraform are understanding what we have here. For those that it's the first time they've seen it or they just started to using it, for Terraform to work, it is better to have, an organized, folder structure and file structure. Okay, so I have here my root folder is AZ Welsh, and I have created 3 files inside here. The first is the main that contains the main configuration. The second is the providers. This is the first file that Terraform looks at when you run the Terraform init command that initializes this directory. The providers file really has to do with which APIs Terraform is going to download, okay, which providers are we are going to create resources and work on, and we really can have here a variety of providers: Azure, AWS, your own provider, or your own private cloud, anything really. So I have to get up for just 30 seconds. Would you excuse me for 30 seconds? Thank you. I'm back with you. Thank you for your understanding. So we're talking about the Terraform file. Here we have also the variables file. I'm hosting my variables on the Terraform cloud, but we have to declare this variable if we want to enter password and username for our managed SQL hosted into our Azure Synapse. And the main file that holds all the configuration. A nice usage of the randomness here is this one, the random string. We can create a random string with any length we like, upper, numerical, lower, or special characters. And when we can apply this into our configuration, so we can have random names, and we don't have to worry about naming convention. Very, very helpful. Our configuration here has created everything, literally, even the administrator for the Synapse Analytics Workspace, system assigned managed identity, firewall rules, containers and blobs, whatever you can think of. You can even import configuration. Here, let's get back right on time to see what happened with our data. We have here a file name masked. Let's have a quick look here directly and see what happened. You can see here that we have the redacted text, and I will download it to have a better look. I think it worked. And let's see what Cognitive Services did for us. I have to say that the pipeline and the copy and the transformed data and the export from the directory can also be automated. You know that either with an automation account or a function. You can write very easily an Azure function that can do that for you. And here is what happened. I'm sorry. This is the redacted text. This is what Cognitive Services understood as personal identification information. And this is the original data. Of course, we could expand more, add more data to our columns, and see what Cognitive Services has to offer regarding more data on our files. So basically, this is our workshop. I'm happy that I managed to complete it because every time I started from the very beginning with Terraform, we have to wait on one hand to finish, and on the other hand, we have to explain everything on Terraform Cloud. I don't know how much time I have left. I think it's 7 minutes, or I'm already 3 minutes late.
Oh, you've got plenty of time. Plenty of time.
Okay. I will take the time just to explain a little bit more about the Terraform Cloud, which is, as I told you before, it is offered free. Of course, the free service has its limitations, but HashiCorp also did a good job here. Can migrate to a new free tier, which is the first time I've ever seen that. A vendor telling me to migrate to another new free tier. But it is fine for me because I can do a lot of things using Terraform Cloud Provider to perform my runs and not worry about storing my state on my local computer. Let's see one quite important thing I think we have to look. These are the variables I told you earlier. So we have the workspace variables. These would be variables that we're going to use to our virtual machines, to our SQL servers, could be shared access signatures, things like that, things that have to do on the specific workspace. Now, because Terraform Cloud uses another structure with the organization and the workspace, I have an organization here, which is the Terraform Labs. This is the name here, quite small. And inside this organization, I have my workspace. Okay. in the level of the organization, I can create variables, and for a better, apply to better apply variables as a set, we can create variable sets. So I have created my variable set, which of course referring to a registered application on Azure Active Directory, created with either with the CLI, AZ create for RBAC, the usual command that we need when we want to create a registered application and perform on behalf of that actions on our subscription. Here we have stored our ARM client ID, the secret, the subscription ID, and the tenant ID, the usual stuff when we want to, as I told you, create a registered application and use it. The important thing is that we are storing these variables as sensitive, meaning that once I save them, no one can see them again, neither in the state. This is very important because it releases me from the anxiety of where I have stored my sensitive information. It's stored on Terraform Cloud, so I can sleep better at night if you want. And for my specific jobs that I run on specific workspaces, I can have many workspaces here. I can create variables on the workspace level, which also can be set as sensitive, right? The only thing here is that we have to declare them. Okay, we have to create this file, and Terraform must know that these are the variables that exist in our runtime when we call the API and run our deployment. Finally, the configuration for Terraform Cloud is quite simple. All we have to do is create a new token. So I will have to go to my user icon in the user settings. You will see here that I have also the ability to create single sign-on, factor authentication, and tokens. I have created a token with a small lifetime. It's not viewable now, but when I created that, it was visible. And what I had to do is go to my local PC, create a file into the app data roaming. Here is the file that Terraform looks at when we have providers as cloud into our configuration. And this is really the file, just 2 lines. Credentials would be the FQDN of the Terraform cloud, and here is our token. So each time I initialize Terraform, and this file here has this reference, it will start to look if I have this file on my local user environment, the app data roaming. Once I have it and the token is correct, it is active, and everything checks out, then Terraform initializes and downloads everything it needs to talk to Azure, AWS, Google. As I told you, a lot of providers there. You can do really nice things with Terraform. Finally, there are some commands I wanted to show you. The Terraform FMT command. This is a command just to make your syntax look better. It does not correct errors, but it will bring, the structure of the code into a more, readable format, just to format your syntax. the command that you want to run before everything, especially when we are starting to use Terraform, is the Terraform validate. Terraform validate will show you if you have something that is inconsistent, something that is erroneous, or you have a syntax error or something you forgot, anything, really anything, before you do your deployment. Once you are sure about what you are going to do, you will run the Terraform plan. The Terraform plan will not apply nothing. It will just create, a blueprint of the resources that are going to be created on your selected provider. It will be Azure for us. Now, because I'm using cloud, I am provided with this URL that will allow me to go to the cloud and see what happened. Let's go back to our workspace. You will see that it is running now. I will have to go to runs. It is completed, so we didn't catch up. And finally, I will destroy what I created. This is the real power of Terraform. We created with some lines of code an extraordinary deployment. We could have data factory, stream analytics, Synapse analytics, virtual machines, virtual networks, storage accounts, everything. And we created our workshop. But we don't want it in the next 12, 24, 48 hours. We may need it in 1 week. I will destroy everything and I will reapply whenever I need it. This is the power of infrastructure as code. I have my infrastructure saved as a code. I made my adjustment. I created my demo, my workshop. I, tested my application, tested everything I needed to test. And then I don't want to keep these resources up and running and, running costs and charging me. So I will just destroy this with the Terraform destroy command. And I can plan and reapply whenever I want to. The communication with Terraform Cloud is very fast. So as long as you run this, you will see already here on the interface what's going on. Of course, when you run apply destroy or destroy, you have to accept this. I can do this from the interface on the cloud or from my VS Code. Only yes is accepted, and it shows me what is going to be destroyed. Really everything. So I confirm and apply. I can set a message if I want to for feature reference, and I'm destroying. Now, this is, I believe, the end of our presentation. I hope you liked it. I hope you saw something new, and I hope you get up to and start using more services like Cognitive Services or Synapse Analytics to really help you what you want to do. I don't know what is failing. I don't care for now. And if you have questions, I'm here to answer for you also. I didn't have time to check.
Thanks so much, Konstantinos. I think everybody's just been enthralled in your presentation, to be honest. I don't think there's been any questions in the chat, but yeah, I mean, look,
Great.
I think, yeah, that's fantastic. I mean, it kind of just shows you the power of, the Azure data pipelines and what you can do and hooking it into various different things and the power of all the template gallery. Yeah, it's been really great to see, to be honest. I've not seen it used in that way. So no, huge thanks for talking us all through that. Yeah, if anybody does have any last minute questions, come off mute quickly or drop it in the chat. But for now, thank you so much, Konstantinos. That was fantastic.
Yeah, I would like to thank you also for hosting me. It was first time here. I hope you liked it, and I hope I will create something new if you take me next time.
No,
I will be my
absolutely. Yeah,
pleasure.
keep in touch, and we'll definitely get back on at some point. Yeah, absolutely. But look, for now, feel free to stick around, Konstantinos. We'll quickly run through our quiz now. So thank you again. Matt, hand straight over to you. We'll get the
Over to
quiz up
me,
and
is
running.
it? Right. So
It's your
top one
turn.
tonight. That's limited people
Let's
tonight.
get number one. Whoever wins gets themselves £25 Amazon voucher.
So you should be able to see that one. I'm going to play that one. And there we go. There's your code ready to go. Ten questions, I think, if I remember what I've done. And they're a mix of, well, there's a load of blob storage stuff, as you might imagine, in honor of John. So you've got no excuses, John, for not getting those right.
How many we got on? We got 9 of us, so 8 we should be getting. Yeah, you got to put yourself a name in there as well. So I don't know who's just joined there with the teeth.
I must have that as a validation thing. Note to self. I keep saying that every month.
I know. So there's other stuff to do though. John, we got Joe, we got Nick, I'm on. Graham, I don't know if you're struggling to get on. Or Konstantinos, if you join. So Graham, Konstantinos, and Steve, you all okay getting on? I'm guessing one of you is the blank one.
Just trying it again now.
Yeah.
I think it put me in as blank for some reason.
Yeah, thanks, Nick. Raising a ticket would be far simpler. And yes, you're right. I should do that.
No,
I'm just being lazy.
Does not like it. Let me try from my phone.
Hope enough.
That's as good a name as any. 3476. As long as it's not the pin to your bank card, you're okay.
Sorry, I'm the 3456.
Is that you, Konstantinos?
Yeah. I thought that the code was there. I haven't used Quizzer before.
That's all right.
I'm sorry
No.
for that.
That'll do, as
There
long as
we
you know
go.
who you are. There's Graham just joined in as well. Steve, I think it's just you. Are you on, or are you the blank one? Or was that you, Graham? I think the blank one was.
Should we just kick off? Is anyone still
Yes,
struggling to get in?
Steve, you okay? Are you all right if we start?
There we
There
go.
he is. On cue.
Right.
Yeah, let's go for it then.
Let's give it a go. Which RBAC role lets you read blobs inside a container? So there's a couple of different sets of RBAC roles for blob storage accounts. There's what's called the control plane and data plane. And you have to make sure you get the right one, which is the storage blob data contributor. The other ones won't. What's the new name for Update Management Center? This is for pushing out updates to VMs, I think, if I remember correctly. It's coming in. It's Azure Update Manager, of course it is. How much does GitHub Advanced Security for Azure DevOps cost per active committer per month? This went GA about a week ago. A fantastic product if you haven't had a chance to look at it yet.
I'm not seeing the questions appear on the screen shared.
They should just appear on. Can you not see the Teams chat?
No. Oh. Yeah, I don't know.
It times was $49. Which of the following is not an Azure AI service? I can reshare if you want, John.
No, it's all right. I think I've got it now.
Is it the
Just slow to
categorizer, the
update.
anomaly detector, the translator, or the vision? It's the categorizer. Yes, I made that one up. What's the maximum size of a record that can be passed to the PII detection skill? There's some things here you've just got to know, I think. Only one of you got that right with 50,000. 50,000 characters, I think it is. What's the maximum throughput of the standard Azure AI language service? It's got throttling on it. In fact, technically it's got 2 throttles on it, but you'll hit the first one at a per second rate. It's 1,000 requests per second. That seems to have split the pack a bit. Which Surface device was not announced this month? The Laptop Studio 2, the Laptop Go 3, the Surface Hub 3, or the Surface Pro 10? That Laptop Studio 2 is an absolute beast of a machine, I can tell you that. It's the Surface Pro 10. No one got that right. It's the only one that didn't. What's the name of the command line tool for moving data to or from blob storage with a spelling mistake in it? Is it AZ copy, robocopy, Xcopy, or Kimono? It's AZ copy. Kimono was a Star Wars joke because they were the cloners. Thank you very much. I'm here all night. What day is Ignite 2023 start? Is it November the 7th, November the 14th, November the 21st, or October the 31st? I hope everyone's registered. If you can yet, I'm not even sure if you can yet. I think I have. It's November the 14th. Ooh. Which of the following is not an Azure storage redundancy option? Is it ZRS, RAGRS, GRS, or ARS? It's ARS, of course. Me being cheeky. And our winner tonight is the mysterious 3476.
I'm just a number.
Konstantinos, well done.
Good work. Good work.
Thank you.
Cool. I will get I'll get that voucher winging its way over to you now over the next few days, Konstantinos. So keep a lookout for your inbox. But there we go. Right then, let's bring this to a close. Let me just quickly get the closing slide back up on the screen. There we go. So yeah, leaves me nothing more to do than to thank our speakers for this evening. So thanks to John and Konstantinos for coming on, giving up your time, talking us through those few subjects there. Really interesting topic areas. Learned a lot personally as well from them. So thank you so much for that. And yeah, as usual, thank you to you all for joining. Good to see some of you back, some familiar faces there. And yeah, please do spread the word. Help us spread the word of the Welsh Azure user group. Tweet and do whatever you need to do. But just follow us on social media and say hello. And yeah, keep in touch. And just to close off tonight, if you do have a couple of minutes, just to kind of scan that QR code and leave us some feedback, that would be superb. But for now, save the date. The next event will be on the 18th of October, usual time, and we hope to see you all there. So thank you once again, everybody. Great to see you all. But until next time, we'll see you all very soon.
Thanks all.
Thanks,
Ta-ra for
guys.
now.
Thanks. Bye.
Thank you.
Thank you all. Bye bye. Good night.